just to summarize, we then have just 3 points here on the benefits of the virtual mapping, and then later the pitfalls. We mentioned this, that we see one of the biggest gains is you can faster go live. So you don't need to use any dummy goods in order to represent a PQ stage. We are also talking with a lot of clients on not necessarily doing a summer and a winter mapping, but doing a spring or fall mapping, because as long as we just have a gradient between the room, a temperature gradient between the room and the neighboring rooms or the outside, to make sure we have a heat transfer, then we can validate our model and make sure it's accurate. So thereby you don't need to wait 3 months if you just miss the summer mapping deadline. And then we talked into these risk of non-compliance, getting early indications, and also this with the energy savings. What I think is also interesting is some of the pitfalls, because going back to my first sort of statement on colors for directors, this is typically used in some industries where it's not been validated. And for this application, we need to have trust in the results, and you need to make sure that it's actually been validated with physical measurements to get an indication of the accuracy of the model. So for example, we saw in one of the projects we did that we compared our OQ measurements to our virtual model, and there was a huge difference between the results. And we didn't really understand, because the virtual model predicted that it was sort of cold near the floor of a cold store, but the physical measurements indicated that we have very warm probes. And the warmest were along the sides of the floor, so just near the concrete slab. And then we went out there and we did a site visit, and that's something we do for all the projects we do. And this is to gather input on so we use our thermal camera to get indications of thermal leakages. And when we use that, we just saw these huge sort of sun streams of temperature or air that was warm near the floor. And that just indicated there was a thermal bridge. So air or heat was transferring through from one room to the other, and thereby heating up the probes. So that's just one example that we need to make sure that whatever we include in the model is accurate. And that also taps into sort of the garbage in and garbage out. We can never be more accurate than the input we get, or whether when we are comparing the physical measurements, they have an uncertainty. We can never be more accurate than that. And that we need to have in mind.